When people's septic tanks and pit latrines fill up, they have to pay for emptying. And this has become a big problem because people who don't have money to pay for emptying actually are disposing of fecal sludge illegally in the channels, and some of them actually open their pits during rain to the environment and actually pollute the environment.
Energy insufficiency remains a challenge in both domestic and industrial sectors worldwide. Biomass remains the major source of energy for more than 80% of the population in East Africa. Hydroelectricity power, kerosene, liquid petroleum gas, and solar energy are expensive for many who use firewood and charcoal. To the contrary, biomass is fast being depleted for multiple use, and deforestation is on the increase due to expanding farmlands and human settlement. Besides energy wars in Africa is the challenge of sanitation, mainly in urban areas where population is on the rise with limited facilities to cater for fecal management. Makerere University College of Engineering, Design, Art and Technology is carrying out research on fecal silage, which is a potential energy source for heating in industries, while at the same time providing a solution to sanitation. In 2010, the college was supported by European Union Splash Program for a 3-year research project in collaboration with the Swiss Federal Institute of Science and Technology, Department of Water and Sanitation in developing countries, West Enterprises in Ghana, and the University of Dakar in Senegal.
The idea was that when we looked at the way fecal sludge management is organized, it is organized in such a way that when people's septic tanks and pit latrines fill up, they have to pay for emptying. And this has become a big problem because people who don't have money to pay for emptying actually are disposing of fecal sludge illegally in the channels, and some of them actually open their pits during rain to the environment and actually pollute the environment. So we thought that if we can demonstrate that there is actually value in fecal sludge, we could actually overturn, so that instead of people paying for emptying their latrines, we have actually, in the end, we are looking at people being paid for, for their fecal sludge. So we started out by characterizing fecal sludge, and the idea was to see if there is energy value and how much it is. We took dried fecal sludge to a laboratory and tested the calorific value of fecal sludge. We found that the calorific value of fecal sludge was as good as that you find from dried coffee husks and actually also from sawdust. In fact, it was about 17 megajoules per kilogram of dried fecal sludge, which we consider to be really competitive and very good as raw material for use in industrial kilns and boilers.
The source of fecal silage are from different sources, from the VIP toilets, septic tanks, and a combination of sources.
We have sludge that came from VIP, lined toilet, septic tanks, and then also a mixture. You know, while they were giving us this sludge, we could record. We had 4 beds and we demarcated them. We want septic here, we want VIP here, and then the rest 2 beds contained the mixture of this sludge. So what is contained in these bags is a variation, the different sources.
This research compares industrial products made through heating of various energy sources like coffee husks and sawdust. In achieving good and acceptable products, various processes are followed at various levels. The processes include collecting the fecal silage, drying it, crushing, sieving, re-drying, sorting and separation from sand.
These heat processes that for which we are purposing to use this fecal sludge, most of them are high temperature heat processes. So before we could demonstrate to industries that need fuel sources about the possibility of using fecal sludge, we had to present actual data, temperature data that shows what temperatures can be achieved when you use fecal sludge for burning or for heating any kind of industrial process. So we obtained data loggers which use thermocouples from Omega Engineering, just like this one, and we use thermocouple wires, and we have positioned them at various points within the kiln, 3 points actually, one at the very bottom of the kiln, another in the middle, and another at the top of the kiln within, so that we could have a feel of the different, the temperature, how it varies within the entire kiln. And this one is actually positioned at the top, and as you can see, we are taking temperatures at every 30 seconds from the thermocouple, and it can show us the temperature at the current at the moment, and you can see that's 360 something, that's 369.5 degrees presently, but then it can also show you the highest temperature that has been gained so far.
Checking for quality at every level of the research is vital, even with the finished products that are later taken for further laboratory testing.
So the sound.
These are the products that we've been burning in our kiln, and just as you can see, earlier on we said it is a research that we are carrying out. So at every level we've been checking what is happening, and as I talked, this is the last batch that we harvested in here, and what is in there we shall harvest it tomorrow evening. Viewers, we just told you about this research on fecal sludge for energy in industries. For now, we are concentrating on industries that use coffee husks, and we just told you that today these products are not available in markets. As coffee prices went low, people lost interest, so they have been going up to Bukoba. And when you get these products, that's why we have such event going high in terms of costs. So as a student of research, having received knowledge that we could do, fecal sludge has some burning characteristics similar to coffee husks. So we went into this business of research. We dried it, crushed it, and we built a kiln where we got these products raw as they were, and we burnt them up to this level. Once these products can achieve the intended research, probably tomorrow we shall not fight with the slum areas where toilets are emptied into the channel and so on, because we shall just have a market for them, and they will be receiving money at home. Yeah, and this is the raw vent which we put into the kiln, and later we receive this out.
There are socio-economic benefits from this research if applied to industries and households that would provide the fecal silage.
We followed up that research by actually constructing a kiln which is based on the designs of kilns that are used by industries around here in Uganda. And the idea was to be able to burn the products that are similar to those they are producing, and to see if we can achieve or obtain the same product by using fecal sludge to burn these products instead of coffee husks and sawdust and so on. The main reason was that when we tried to do a market demand study of fecal sludge in Uganda, we in fact found that some industries were getting a problem because coffee husks are no longer enough in Uganda. Some of them were going as far as Bukoba in Tanzania. So we set out to demonstrate to them that actually instead of going up to Bukoba, we have here material which is in sufficient quantities, and this material can actually produce energy that is needed in these industries. In fact, it is estimated that about 1,000 tons of fecal sludge could be produced here in Kampala alone on a daily basis. And that could actually contribute a lot in terms of the energy requirement for industry.